sea waves of wavelength 150 metres and velocity 15.3 metres per second are heading north. Cruise ship is also travelling north at 8 metres per second. Calculate the frequency of the ship's up and down movement. So what we're going to need to do is think about relative velocity here. Let's leave that one on. We'll leave the equation there. So here we go. There's our cruise ship. It's heading north 8 metres per second. That way, the waves are going at 15.3 metres per second. They've got a wavelength of about 150 metres. Cruise ship, big cruise ship will be a bit longer than that. Possibly a bit longer than that. Anyway, 150 metres, heading that way. Frequency of the ship's up and down movement. So basically what's going to happen is that we need to do a relative velocity because these waves are going to catch up the ship. But because the ship is moving in the same direction, the net velocity is going to be slightly lower. So we want the velocity of the wave with respect to the ship, or the other way around. So we want the velocity of the wave with respect to the ship, because that means if you're on the ship, what do you actually see? So with respect to basically means in maths terms minus. So we want v wave minus v ship. These are vectors. Let's put a vector sign under. So we've got 15.3 metres per second north minus 8.0 metres per second north. So 7.3 metres per second north. I don't think the direction is going to come into it. There's our net velocity of the wave that the ship experienced, 7.3 metres per second. We want the frequency now, so we know the velocity, we know obviously v equals f lambda. Did do it the right way around last time, didn't I? It would have been, because otherwise I wouldn't have got the units right. Sort of look at what I've stuck there, but the units wouldn't have come out right. So velocity is frequency times wavelength. So we know velocity, we want to find our frequency. Wavelength, well, we know velocity, we can find wavelength. So lambda we can get from equation 1. Now, we've already determined that term is negligible. 2 pi gamma over lambda rho is negligible. Just get rid of it, doesn't come into it. So we've got v squared equals g lambda over 2 pi, which implies that 2 pi v squared equals g lambda. Lambda equals 2 pi v squared over g. So now we can find frequency. So frequency is velocity over lambda, which equals our velocity over 2 pi v squared over g. Bring the g up, cancel one of those v's, so that's g over 2 pi v. .81 meters per second squared over 2 pi times 7.3 meters per second. Quite a smallish number, but that's what you expect on a ship. It doesn't go up and down at several hertz. .21. I think two significant figures here. Hertz, just check units. Meters go seconds to the -2 over seconds to the -1 is per second, which is a hertz. And that seems reasonable. 5 second periods, reciprocal of that. 10 divided by 6, about 1 and a little bit. Divide that by 7, it's going to be about 0.2-ish.